This lesson we're going to talk about Gauss-Jordan eliminations, which is matrix system. This lesson we're going to have more than 2 variable or 2 equations. Here you can see you have 3 variable with 3 equations. No matter how many variable you have, how many equations you have, bottom line is trying to make diagonally 1 and everything else 0, and solutions on the other side, so that x, because your yz is going to be 0, so your x is a, y is b, and z is equal to c. So this is your goal, trying to make every diagonally 1 and everything else is equals to 0. And we usually start from the bottom, right? Making these 2 zeros. So this is going to be first one, this is going to be second 0 we wanted to make, and this is going to be the third 0. Right? And sometime, instead of making everything else 0, we will stop there, and once we find the z, we can replace with z into the second equations to find y, and then with the z and y, you should be able to find x. And I'm going to show you what that means. Okay, so bottom line, you wanted to make diagonally 1 and leave the bottom 3 value 0. Okay, so this 0, and let me just show you what the examples. So let's change the equation into the matrix first. So copy the first equations, just the number without the variable. X have 2, y have 1, z have -1, solution is 2. Second equation, I have x1, y3, z2, 1. Third equations, 1, 1, 1, solution 2. So remember, I wanted to make this one 0 first. And this is already 1, so maybe if I multiply the row 2 by -1, it will be opposite. So I will do row 2, let's multiply that by 1, -1. And as it is row 3, combine, I will get the first value 0. So row 2 multiplied by -1 is -1, -3, -2, -1. Row 3 as it is 1, 1, 1, 2. When you add them up, you get, that will be 0. This is going to be -2, -1, and that's +1, right? And then you wanted to make one more 0 here. So let's do that one second, and that's third, right? So let's find that one 0. One more 0 with the first columns. We use the row 2 and row 3, so we need to use the different mixture. Okay? We cannot use the same row twice. If it's a new row, then it will be okay to use it, but if it's the same row, you cannot use the same mixture. So since we use 2 and 3, we need to use maybe 3 and 1, right? Let's use 3 and 1. So this time, using row 1 with row 3. Row 1 is 2, 1, -2, and 2. So in main row 3, I need to multiply that by -2. So I will get -2 there. -2, -2, -2, and -4. When you add them up, you get 0, -1, -3, -2. So this is going to be, one of this is going to be new row 2, new row 3. It's up to you which one you wanted to make it. It could change the order. So let's just make it this one new row 2. And let's make this one new row 3. So that means this matrix system now will look like 2, 1, negative 1, 2. And then 0, 2 is 0, negative 1, negative 3, negative 2. 0, 3 is 0, negative 2, negative 1, and 1. Now using these two new rows, you should be able to get rid of negative 2. In order to get rid of negative 2, what do you need to do? You wanted to do mixture of new row 3 with new row 2. And you wanted to multiply new row 2 by 2. I mean negative 2, right? So new row 2, let's multiply by negative 2. So new row 3 is 0, negative 2, negative 1, and 1. New row 2 times negative 2 will be 0. That will be positive 2. That will be positive 6. That will be positive 4. Add them up. I get 0 and 0 and 5 and 5. And I can tell if I divide all this by 5, I will get 0, 0, 1, 1. Right? So I can make that one as the new row 3 or solution row. Let's call it as a solution row because you already have 2, 0, 1, and 1. So that's going to be solutions row 3. And also at the same time, maybe I can divide everything by negative on row 2. To make it positive numbers. And this makes it positive 1, right? This will be 3 and this will be 2. Just copy down the first row, 2, 1, negative 1, and 2. Here you have options after this. What do you mean? Well, so if you wanted to stop and use the substitution method, you should be able to because you found one solution. That's not why that's z equals to 1. You found one solution, and the next row, second row, is equation with 2 variables, which is 1y plus 3z equals to 2. So you can use these substitutions to find your variable y from the second row or second equations. So when you replace this to here, you will get 1y plus 3 times 1 equals to 2. So y equals to 2 minus 3, where y should be negative 1, right? Once you have z and y value, you replace that into the first equations. Remember first equations, right? This is 2x plus y minus z equals to 2. Now you have z and y, so replace that here and find x value. That will be 2x minus 1 equals to 2. That's 2x minus 2 equals to 2. You add both sides by 2. 2x equals to 4, where x is equals to 2. So you end up getting solution set. So let's use the parenthesis. So solution set of x2, y negative 1, z1. So that's the solution set you're going to get if you're using the substitution method. Or you can continue using this to make this value to make this one 0, right? You can do that by multiplying this by 3. So if you multiply the solutions, row 3 by -3, you will get 0, 0, -3, and -3, and use the new row 3. That's 0, 1, 3, 2, which will give me 0, 1, 0, -1. You could do that to find your y value. This is y equals to -1. So that can be solution row 2, right? So y is equals to -1, which is the same. And using this solution row 2 and solution row 1 to create this value 0 and this value 0. And you can find your x. So you can keep doing eliminations method to find your solutions, or once this 3 is 0, you can use substitutions to find your solutions. It's up to you. Okay. Now we wanted to try B. So let's try B. We have matrix system. This is B. Matrix systems 2, -1, 3, and solutions. Second equations gives 1, 2, -1, and 6. Third equations is -1, -1, +1, -5. Okay, so by just adding itself, row 2 and row 3, 1 and -1 is opposite, so we should be able to make first column 0, one of them, right? So let's do that. 1, 2, -1, 6, -1, -1, 1, -5. Add them up. I get 0, 1, 0, 1. Oh, I know I wanted to use this as new row 2. Because remember, new row 2, so where gold is this. But then the second row is the one that have middle value 1 and the other side is 0. And I already have that here on this one, right? So since I can make this as the new row 2 or new row 3, I know I wanted to make this one new row 2 because it's already satisfied middle value being 1, right? Let's try another one, but this time I cannot use the same combination row 2, row 3. So let's use row 1 and row 3. And row 1 is 2, so we need to multiply row 3 by 2 to make it -2. Row 1 is 2, -1, 3, 2. And row 3 times 2 is -2, -2, 2, and -10. When we're adding, we will get 0, -3, and that's 5, and that will be -8. So then this had to be new row 3, right? So let's write that first. 2, -1, 3. So first row will just stay same. Second row, I already have our solutions. The third row, 0, -3, 5, -8, right? So at this point, again, you have options. You have one solutions already. say y is equals to 1. And you have an equation with two variables, which is negative 3y plus 5z equals to negative 8. And you can replace this here to find your z value. Once you find x, y, and z, you can replace it in the first equation and find x, right? So once you have one solution and one equation with only two variables, you can use the substitution method or keep doing the row eliminations to find x, y, z. Everything else is 0, right? I will just do the substitutions here. So if I do substitutions, my z is going to be negative 3 times 1 plus 5z equals to negative 8. So that gives you 5z equals to, adding both sides by 3, so it will be negative 5. Divide both sides by 5, z will be negative 1. Once I have y and z on one of the equations, use one of the equations to find x. So it will be x minus 1 plus 3 times negative 1 equals to 2. This gives you negative 1, negative 3, so it will be negative 4 equals to 2. So when you're adding 4, you get 2x equals to 6. Divide by 2, you get 3. So solution set should be 3, 1, and negative 1, right? So that's how you can find it. I can also show you a little further if you wanted to use a matrix system all the way. Let's see what I need to do. I will do new row 2. I need to make this one 3. So times 3. And then add it into new row 3, right? Then it will get 0, 3, 0, 3. And this is going to be 0, negative 3, 5, and negative 8. Add them up. I get 0, 0, 5, and negative 5. And when I divide this by 5, I get 0, 0, 1, negative 1. So my z is equals to negative 1, right? Which is the same. So if I wanted to make matrix, I have solutions row 3. I have 2, negative 1, 3, 2, 0, 1, 0, 1. And this being solutions row 3, so it will be 0, 0, 1, negative 1, right? That will be the matrix. So Z solutions, negative 1, Y solutions, 1. Using that, plug in it here and find your X, right? Or make this 2, 0 and find your X. It's up to you. Let me do one more matrix. This time I'm going to do all the way. And let me pick the C. If you wanted to see or need help with the other two, email me and let me know, and I'll be able to send you my work. Or look at the lecture notes. I have all the work written. So when I'm looking at the C, I see I have X, Y, and no Z on the first equations. And second equations, I have all mixed, right? And I have X on the other. So the first thing I wanted to do is rewriting all this in a right format, same format as the other. So I will have X, Y, no Z, so it will be space. And then when I move X to the other side, it will be negative 2X. And I have negative 3Y, and then plus 2Z equals to negative 2. And I have X, I have Y, and my Z is on the other side. So when I add it, it will be 5Z on the left side. and solution will be 8. So I'm going to use that order when I'm creating a matrix. So it will be first equation, x is 1, y is 1, z is 0, and solution is 3. X is -2, -3, 2, and -2. Third equation, I have x is -1, y -3, z 5, and solution is at 8. So this is what I'm starting with. So all the first column x, second column y, third column z. Let's see, I wanted to make this. I wanted to create 2 new row with first column 0. So let me do row 1 with row 3. Look like they are already opposite. So just by adding them, I will have first column 0. That will be -2, 5, and there will be 11. I wanted to see what else I'm going to get when I'm trying to eliminate. So let me do different mixture this time. So let's do row 1 with row 2 this time. Row 1 with row 2. Row 2 is -2, so I will multiply 2 to the row 1 to make it opposite 2, right? So that will be 2, 1 times 2 is 2, 1 times 2 is 2, 0, and 6. Row 2 itself is -2, -3, 2, and -2. Add them up, I will get 0, -1, 2, and that will be 4, right? I will just multiply this by -1 equals 0, 1, 2, -2, and -4. Let's make this one new row 2 because I make the second column 1. Let's make this one new row 3. Then you will have 1, 1, 0, 3, and 0, 1, -2, -4. You have 0, -2, 5, and 11. Now let's try to make solution row 3. Solution row 3 means you wanted to make this one 0. Right? In order to do that, maybe I will use the new row 2 with new row 3. In order to make it opposite, I will multiply new row 2 by 2. So that get 0, 2, -4, and -8. New row 3 is 0, -2, 5, and 11. When you add them up, you will get 0, 0, 1, and 3. So this become your solution row 3. So when you write the solution row 3 after that, you have 1, 1, 0, 3, 0, 1, -2, -4, and 0, 0, 1, 3. So just looking at this, you can tell 1z is equals to 3. So that's what third row give you. With that, you can replace that into the second equations. Second row, which is y minus 2z equals to -4. Replace z by 3 to find your y value. You will get y minus 6 equals to -4, so your y is going to be +2 when you're adding both sides by 6. So you have z equals to 3, y equals to 2. Your first equations give you x plus y equals to 3. So when you replace x by 2, y by 2, your x is going to be 1 because you're subtracting both sides by 2. So your solution set is x1, y2, and z3. So this is how you're going to use your matrix systems to solve any types of linear equations, a system of linear equations.